In this video, we are going to look at the reaction mechanism for the formation of acetals. And maybe if you don't know what acetals are, acetals involves organic compounds where we have two ethers sharing one carbon. Now, acetals are going to be formed by the reaction of aldehydes and alcohols in presence of an acidic medium. And if you are new here, please take a second or two, then subscribe, like, and comment the video. Now let's start. Now we are having our aldehyde here. This is our aldehyde, R, C, double bonded O, then bonded to hydrogen. So this is an alkyl group and connected to this, C, double bonded O, and then H. And then we are going to react it with alcohol in presence of an acidic medium, H ion. Now, we shall have this oxygen picking on hydrogen ion, so that they form CH double bonded O with H. So after picking on hydrogen, this new compound is going to be formed. Now after forming this, you realize that this oxygen acquires a positive charge, because oxygen is always stable with two bonds. But now we are having three bonds here, 1, 2, and then another bond bonded to hydrogen. Now becomes 3 bonds. So oxygen acquires a positive charge. Now we shall have this alcohol attacking now this carbonyl. After attacking this carbonyl, we shall have a new compound formed here. The reaction is reversible, so we shall have R, C, then H, then OH, positive charge, then oxygen now attach itself there with hydrogen and alkyl group. Now after forming this, you realize that this bond shall open up so that to neutralize this positive charge, and also this oxygen here shall acquire a positive charge because it is having 3 bonds, 1, 2, and 3. So the new product formed here, we shall have now this bond is gone, so this shall be having a single bond here. So we shall have R, then C, then one bond there, OH, then bonded to hydrogen, then bonded to oxygen, H, and then R. And this is positive. Now, after arriving here, we need to neutralize this positive charge here. So we shall have this bond collapsing to neutralize this positive charge, and this hydrogen shall leave. So we are going to have hydrogen leaving, hydrogen, so minus hydrogen, so that this bond breaks like that. So we shall have R, then C, then H, then O bonded to H here, then our O and R. Now the hydrogen has left. Now, after arriving here, we're going to add hydrogen again. So we are going to add hydrogen ion here, hydrogen ion. So the reaction is reversible. The hydrogen ion shall get attached itself here to form R, then C, then H. So it shall get attached itself there. Shall have oxygen, then with 2 hydrogens there, then with our OR here. Good. Now after having this becomes now oxygen acquires a positive charge here because it is having 3 bonds. Remember, this is 2 hydrogen then plus 1 bond. it becomes 3. So we are going to remove this whole group, and realize that this is water, and water is known to be a good living group. So we are going to remove water from that constitution. So we shall have RCH. Now water shall live, being a good living group, and this oxygen is having a lone pair of electrons. There are 2 lone pairs of electrons. So this lone pair shall collapse and form a double bond here. So we shall have, so that we have O bonded to R like that, and this water has left, so that we have carbon with 4 bonds, 1, 2, 3, and 4. Now after writing it like this, you realize that oxygen again, it is having 3 bonds here, so it is having a positive charge. So we need to remove this positive charge. Remember, here we were removing water. So we are removing water. So this positive charge needs to be removed. And how are we going to remove it? So we are going to introduce another mole of alcohol. So another mole, the second mole of alcohol. Now, so that this alcohol shall attack this carbon here. So we shall have this, let me write like this. So this oxygen shall attach itself in this carbon, but on the upper side. So we have R, then C, then H. Let me write this group on top here, so that we have this O, then R, so that this alcohol group gets attached itself here, so that we have our alcohol there. So that you realize here, these are 3 bonds. So our oxygen has acquired another positive charge. And how are we going to remove it? So we are going to remove it by removing this hydrogen ion. So we are having the removal of hydrogen ion, so that this bond can collapse, this bond can leave, so that we remain with the 2 bonds there. So we shall have this here. This is the removal of hydrogen. So we shall write it, this R, then C, then H, then we have our O, then R. Remember this hydrogen has left, so and then introduce this O, then R. Now, after introducing that, you realize that this carbon is having extra bonds. So we need to, and also this oxygen here has acquired a positive charge because it is having 3 bonds, 1, 2, and 3. So we need to break this bond to neutralize the positive. We break that bond to neutralize the positive charge here, so that we have, at last, we arrive at R, then C, then H, then our O and R, then here we have O, then R. Now, after arriving here, you realize that this is an ether group, one group of ether, then we have another group of ether here. And from our definitions, we say that acetals involves 2 ethers attached to 1 carbon. So this is evident here. We have 1 ether, then the second ether being attached in 1 carbon. They are all sharing this carbon. Now this becomes our acetal. This becomes our acetals. So this is our final product, acetals. Thank you for watching.